GPT-2 is not very good with Python, and it's not anything to do with coding or the language model itself. It's just that if you use a lot of indentation using space in Python, like we usually do, you just end up bloating out all the text, and it's separated across way too much of the sequence, and we are running out of the context length in the sequence. That's roughly speaking what's happening. We're being way too wasteful. We're taking up way too much token space. Now, we can also scroll up here and we can change the tokenizer. So note here that GPT-2 tokenizer creates a token count of 300 for this string here. We can change it to CL100K base, which is the GPT-4 tokenizer, and we see that the token count drops to 185. So for the exact same string, we are now roughly halving the number of tokens. And roughly speaking, this is because the number of tokens in the GPT-4 tokenizer is roughly double that of the number of tokens in the GPT-2 tokenizer. So we went from roughly 50K to roughly 100K. Now you can imagine that this is a good thing because the same text is now squished into half as many tokens. So this is a lot denser input to the transformer. And in the transformer, every single token has a finite number of tokens before it that it's going to pay attention to. And so what this is doing is we're roughly able to see twice as much text as a context for what token to predict next because of this change. But of course, just increasing the number of tokens is not strictly better infinitely because as you increase the number of tokens, now your embedding table is sort of getting a lot larger. And also at the output, we are trying to predict the next token, and there's the softmax there, and that grows as well.